Hey there, this is MathCamp321 presenting to you the solution to number 12 of the PARCC Algebra 2 practice test. In question number 12, it states that Paul started to train for a marathon. The table shows the number of miles Paul ran during each of the first 3 weeks after he began training. If this pattern continues, which of the listed statements could model the number of miles Paul runs, a sub n, in terms of the number of weeks n after he began training? Select all that apply. So the first thing that I notice when I read this problem is the phrase, if this pattern continues. And this phrase signals to me that this is going to be a question about sequences. Now there are two basic types of sequences. One is arithmetic and the other is geometric. The graph of an arithmetic sequence, if you were to plot the points, would look like a line. If you were to plot the points of a geometric progression or a geometric sequence, the graph would not look like a line, but it would look like an exponential function. Now, to decide what kind of sequence you have to look at the data given to you. And if we look as the weeks go on, he starts off in week 1 running 10 miles. In week 2 he runs 12 miles, which is a difference of 2 miles from week 1 to week 2. But as we look from week 2 to week 3, he transitions from 12 miles to 14.4 miles, which is adding 2.4 miles. So from week 1 to week 2, he adds 2. But from week 2 to week 3, he adds 2.4. So he's not adding the same exact amount each time. For this reason, I know it's not an arithmetic sequence, because in an arithmetic sequence, you're either adding or subtracting the same amount each time to get from term to term. And here we're first adding 2 and then we're adding 2.4. So because this is not the same value each time, I'm going to decide that this is not an arithmetic sequence and that it's geometric. Now, when you're working with a geometric sequence, you don't have a common difference, you have a common ratio. So to figure out what the common ratio is, you can get your calculator out and you can divide 12 by 10. Dividing 12 by 10, we end up getting 1.2. What that means is to get from the first term to the second term, I have to multiply by 1.2. And then to get from the second term to the third term, once again, you're going to multiply by this thing, 1.2. And this value, 1.2, is known as the common ratio. And for this problem, the common ratio is 1.2. Now the other thing that I'd like to highlight is the geometric sequence general formula, which is a sub n equals a sub 1 times r to the n minus 1. So this a sub n stands for any term in the sequence can be found if you know the first term. A sub 1 is the first term. R, of course, is the common ratio. And then whatever term number you're looking for, which would be generalized with this variable n, you're going to subtract 1 from that for the power of r. So generally speaking, we could say that for this particular scenario, any term can be found by taking our first term, which is 10, multiplying by our common ratio, which we discovered to be 1.2, and then raising that to the n minus 1 power. And this is actually revealed in answer choice C. Now I can safely eliminate some of the other choices. Choice A, if you were to distribute the 2 through, would end up giving you the equation of a line which is linear, which would be an arithmetic sequence. And we decided that it is not arithmetic. In letter B, or choice B, this would be the graph of a parabola. And our two choices are either going to be an arithmetic sequence, which looks like a line, or a geometric sequence, which looks like an exponential function. And this is a parabola, so that's not going to work either. Now, choices D and E are recursively defined sequences. And what they're doing in each of these is they're giving us the first term, and they're stating that the first term is 10. So the first term is in fact 10. We can see that right up here. So this right here is not really a distinguishing characteristic because they both start with 10. So it's really a matter of looking at this over here. If we look at answer choice D, it says the first term is 10, and then it says any term is going to be 1.2 times the term before it. If we look at a number line for a moment, and I call this n, the value right before it would be called n minus 1. So if we think of this as any term, then this term before it would be called the previous term. So in choice D, the first term is 10, and any term on the list is going to be 1.2 times the previous term. And this also works, so this is also a valid choice. And very quickly, just checking answer choice E, this states that the first term is 10 and that any term is equal to 2 more than the term before it. And that's not necessarily true. From here to here is 2 more, but from here to here was 2.4 more. So the two answers that work are answer choices C and D for this geometric sequence.